Okay. From now on, I'm going to have a class on regression analysis. It will be similar to what we have done in the past. So in the previously, we have done a simple group study of doing linear regression by just calculating the fitting a linear regression model by your hand. And then we have thought this as a training data and these as a test data. And we have calculated the mean MSE value for this kind of, for the training data. And we have predicted a new student's weight by using the fitted model on the training data. In this lecture, we are going to do once again with these kind of issues, this kind of examples, but in this time you're going to solve this on the multiple linear regression problem. So what is the problem is that since multiple linear regression problem cannot solve by your hand is very difficult. So in this case, I'm going to use very basic Python coding and solve this problem. So today, what we are going to do is that we are going to use this kind of housing data. And in this housing data, what we are going to predict is this MEDV value, which is the how much the each of this data, each of these instances denote houses in Boston, and these are their some attributes related to house, which this one is like how much there has been criminal in this neighbor, and maybe this is about how many there are teachers in the city, and maybe this one is how much rooms that you have in this house. So every instance is a house, and by using these values, we are going to predict the MEDV, which is the value, median value of the house. So this is what we are going to do. So since we have, but we are not going to use all of this data. So we are going to only use these kind of 5 values and predict MEDV value. So using these 5 attributes, we are going to predict our MEDV value. So to make training data X, so we have to drop all these values, and we can get a data X, which is the X data, and the data Y, which is the MEDV value. So in this case, we are going to fit a multiple linear regression problem, which we have 5 attributes and 1 target variable with it. So since we have learned before, in the previous case, you guys, you have done linear regression, which is the closed form equation is in here in 11, page 11. However, in this case, since we have 5 attributes, we need to use the closed form of the multiple linear regression. So I know many of you haven't learned about linear algebra and didn't know how to calculate these kind of matrix computations. However, what you need to know is that you need to, when you have the values X and Y and calculate these kind of mathematical form, we can get a beta, which is the weight of all this data. And by multiplying X and the weight, we can get a predicted value for the MEDV value. So what we need to do is that we need to calculate this thing to calculate the optimized W. So in the linear regression, we have calculated this one, but in the multiple linear regression, we need to calculate this one. So after this, we have data X and data Y. So this is the data, and we have to predict a model that can predict data Y. So as I told, before we start, we need to split the data into training and the test data. So this is the function that we can divide the training data and the test data. And in this example, by using train test split, we can split the data into training X and X training Y, and test X and the test Y. So now we can split the data. So what we're going to do is that we want to calculate the W. The W will be shown like this. X, this is transpose X transpose X, and multiplied their X transpose Y. So to calculate this, this one is called inverse with it. So this is X transpose X inverse X transpose Y. And we can calculate this one by using computer. So this is X transpose X, and their inverse. And then if we calculate this one with the Y, we can get a W. So if we know all the X and all the Y, we can get an optimized W or beta with it. We can get the optimized weight. So if we see this weight, it has 5 values. So first is this one, second, third, fourth, and fifth. So how does this use is that if we want to predict the Y value of this, the first instance, what we need to do is that we have to calculate this one, the first weight. So this multiplied by this, and this multiplied by this, and this one, and this one, and this one, and this one, and finally this one, and this one. So if we multiply all these values and their instances in the X, then we can, so this is the Y we need to predict. However, if we multiply this one and all other instances, then we can get a predicted Y. So this is a predicted Y by multiplying the X and the W. So if we multiply, this is the real Y data. However, we can get the predicted Y like by multiplying this one and this one. Then, so this is a true value and the predicted value. If we find the difference between those two values, we can get the residuals. So since we have more than 100 data, this is all the residuals for the first data, second data, and the third data. So these are the residuals of the data. So in this case, in this case, we have calculated the predicted weight and the real weight, and we have calculated the error. And in this multiple problem, this is the error, which is the difference between the training Y, real Y, and the predicted Y. And then if we calculate the square and calculate the average value, we can find that the MSE is about 34 in this problem. And in this, by using this X data, and we need to apply for the test data. So to predict a test data, we need to multiply the W and the X, the test data of the X together. And if we multiply these two, then we can get all these values. So we can calculate all these values. This is all the predicted Y of the data. And then since this is the real one, we need to calculate the difference between the predicted one and the real one. And if we calculate the square and calculate the mean, and this is the MSE for the test data. So since MSE data for the test data and the training data is similar, we can find that there is no overfitting issues in this problem. So this was a very simple simple regression analysis, which is the multiple version of the group study. I hope you have understood how it is going. So if you know all the X and all the Y, you can predict the values. Thank you for listening. And I'm going to upload a Korean version in the next video. Thank you for listening.